This video is going to look at inverse variations. An inverse variation means that when one number goes up, the other number goes down proportionally. What that means is that x times y, the two different numbers, will always equal the same number, which is typically known as k. It also means that x equals k over y, or y equals k over x. Let's take a look at an example of a set of numbers that vary inversely. We're going to have the x numbers and the y numbers. The x numbers are 6, 7, 10.5, 21, and 42. The y numbers are 7, 6, 4, 2, and 1. And you can prove that these vary inversely by multiplying all of these numbers together. 42 times 1 is 42. 21 times 2, 42. 10.5 times 4, 42. 7 times 6, 42. 6 times 7, 42. These numbers right here would be k. And we just proved that they vary inversely because we multiplied all the x's and the y's by each other and we got the same number. Let's take a look at how to graph inverse variations. If you're given a function that says f of x equals 6 over x, we're actually going to use 8 magical numbers here in order to graph this, and you'll see why in a minute, but it's basically because there's going to be two different sets of points in this graph that add up to two different curves. So we're going to use our x's and our y's. X is going to be -3, -2, -1, -1/2, and then all of those, the opposite of all of those numbers, which is 1/2, 1, 2, and 3. Now what we need to do is we need to put in these numbers. I'm not going to bother erasing so much as I might have before because I'll probably have more room. When f equals -3, you have 6 over -3. 6 over -3 is the same thing as -2. When I have f is -2, I have 6 over -2. 6 over -2 is -3. When I have f equals -1, I have 6 over -1, which is -6. And when I have f is 1/2, and if this is getting challenging to see, we can do that, I have 6 over 1/2, which actually means 6 divided by 1/2. Now we need to multiply the reciprocal. The first number stays the same, just stays 6. We can also write it as 6 over 1 because it's in a fraction. Division sign changes to multiplication. 1/2 changes to 2 over 1. 6 times 2 is going to be 12. And we can't forget that negative sign that was at the 1/2, even though I just did. So we need to make sure that we put that negative sign in there. Now we're going to do the opposite of all of these. We're going to erase and redo it just to make sure that we really have shown all of our work, because you won't be erasing on your loose leaf paper, and to make sure that we did it correctly. This is a good way to double check our work. When f is 1/2, we have 6 over 1/2, which would be 6 over 1 divided by 1 over 2. 6 over 1 times 2 over 1, which is going to be 12. When f is 1, we have 6 over 1, which is just going to be 6. When f is 2, we have 6 over 2, which is going to be 3. And when f is 3, we have 6 over 3, which is going to be 2. Now we get to graph this. Here's where it might start to look a little bit intimidating. Looking at my graph, on the x-axis, all I need are up to 3. But on the, there we go. But on the y-axis, I need to get all the way to 12. So what I'm going to do is I'm going to graph using even numbers here. So this is going to be 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12, 2, 4, 6, 8, 10, 12. Looking at this, you would never know that I've graphed using only even numbers for lines. So what I'm going to do to show that, rather than write all of the numbers, which is going to start to get to look really crowded on here, is I'm just going to put the first number on each side. That way you know that this is 2, this is 2, these are all 2's, which means everything else is going to be the same increment. So first thing I want to graph is -3, 2. So I'm going to run -3, fall 2, and then I have -2, -3, -2, -3, then I have -1, -6, 2, 4, 6. And then I'm going to have -1/2, which is actually only going to be a quarter of this, so it's almost going to look like it's on the line. -1/2, -12, 2, 4, 6, 8, 10, 12. You can see kind of what I have going here. I kind of have a curve going here. Let's take a look at where the rest of these points fall. I have 1/2, 12, 1/2, 12. I have 1, 6, 1, 6. I have 2, 3, and I have 3, 2. And you can see that this is actually forming kind of an opposite curve, so there's almost looks like there's a mirror here, like it's being reflected across a line. And this is what an inverse variation looks like. Let's take a look at one more. Let's take a look at when f of x is 2 over 3x. So this one's going to be a little bit more complex. I'm going to get all my numbers in there. -3, -2, -1, -1/2, 1/2, 1, 2, and 3. Now I get to put all of these numbers in for x. I've got all this work to show off to the side. I'm going to try to keep the board centered so that you can actually see it as well. When f is -3, I have 2 over 3 times -3. I want to do what's on the same level first. 3 times -3 is going to be -9. 2 over -9 is actually going to be -0.2 repeating. So I'm going to write 2 with a line over it. When f is -2, 2 over 3 to the -2, 3 times -2 is -6. 2 over -6 actually turns out to be -1/3. 1/3 is 0.3 repeating, and this is a negative number. Let's go ahead and look at -1. 2 over 3 times -1. 3 times -1 is the same thing as -3. Whoops. And then I have -2/3, which is going to be the same thing as -0.6 repeating. I'm going to try to make these repeatings as obvious as possible. And then the last one is going to be 2 over 3 times 1/2. 3 times 1/2 is actually going to be 0.5. Oh, this is a -1/2, so it's going to be -1.5. 2 over negative 1.5 is actually going to be 1.3 repeating, negative 1.3 repeating. And this just gets all sorts of fun. And now we're going to do the opposites, which should end up being the exact opposite numbers, but we're going to double check to make sure that we did our math correctly, because there's a lot of little things that could have been overlooked. And we also want to show our work. So when f is 1/2, we have 2 over 3 times 1/2, which is 2 over 1.5, which is going to end up being 1.3 repeating. And yes, I am doing this very fast. I'm doing this very fast because I'm using a calculator to do the multiplication and division. That is okay to use a calculator when you're working with inverse functions and other things that are complex of this nature. If you're given a problem 7 times 2, you don't punch that into a calculator. But if you're given problems like these, the point is not to test your multiplication skills. The point is to test and see what you know how to do on here. When f is 1, we have 2 over 3 times 1, which is just 2 over 3. 2 over 3 is the same thing as 0.6 repeating. When f is 2, we have 2 over 3 times 2. I can actually just cancel out the 2's and know that I have 1/3, which is going to be 0.3 repeating. And then when I have f is 3, I have 2 over 3 times 3, which is 2 over 9, which is going to be 0.2 repeating. Now what I get to do is I get to graph this. And when I graph this, even though it is sometimes you see that people will have different, they'll have different types of the way numbers are spaced on here. I choose not to do that because I like to see the way the graph should look when it's actually graphed on a consistent basis. So I know I don't have to get any bigger than 3, so I'm going to try to give as much room as I can for each of these. So I have 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. I'm not going to say anything about what each of these marks mean, so you can just assume that they're all going to be one whole number spaced between. My first number is -3, so I'm going to run -3, and I'm going to fall -0.2 repeating, which can be a little bit challenging to think of. 0.5 would be here, so -0.2 would be somewhere very, very close to that -3 point. I have -2, which is here, and then -0.3, which is going to be just a touch down from the other point. And it's very hard to see. I understand that. This is just sometimes the nature of the problem is that they're just really close to each other. -1, -0.6, so I'm going to go about halfway down, a little bit more. And then -1/2, which is here, and 1.3 repeating, which is going to end up being right about here. Let's graph the rest of these. 1/2, 1.3 repeating, so I can run 1/2, jump up 1 1/3, run 1, jump up 0.6, run 1, 0.6, well 0.5 is here, so 0.6 is roughly going to be here. Run 2, jump up 1/3, and then run 3 and jump up 1/5 or 0.2. And there we can see that we have an inverse variation.